Hi, I am Chen. Today we are going to demonstrate how to create building dimension in 3ds Max. Integration with Volumebreaker and Thinkingparticles. This is our workflow. Breaking your model into pieces and set up Thinkingparticles to run the physics simulation and the rendering with mental ray. This is my startup scene. You can see a building, a ground, and a sphere. Before you cut your building into pieces, make sure your model is a solid model. You can add a STL check to see if there is any open edge, double faced spike, or multiple edges. Make sure there is no error for your model, since it will take very long time for Volumebreaker to calculate this complex building. I suggest you create a very simple box next to your building to test the parameter for Volumebreaker. Now, let's apply a Volumebreaker modifier to this box. Let's focus two parameters here. One is raster, another is density. Both will control the number and the size of your fracture parts. Let's start with density around 500. This creates a homogeneous result. What if we want the fracture in is relatively to the impact point? We can switch from homogeneous mode to spherical density. And we have a radius 1 and radius 2. Here I explain what is radius 2. This is when radius 2 is 100, and this is 200 and 300. So basically, is radius 2 indicate the area of your impact point, the size of your impact point. And let me explain another parameter, the density 2. This is when radius 2 is equal 100 and density 2 is 1. This is when density 2 is 2. This is when density 2 is 5. So you can see basically is density 2 is the area behind the radius 2. Once we satisfy with all these parameters for the Volumebreaker on this simple box, we now focus on this 3D building. First of all, we set key for this sphere. So as you can see, basically the impact point is around here. So we select our 3D building and adjust its pivot. To the position when the sphere hit this building. Once we adjust the pivot of our 3D building, now we can copy the Volumebreaker modifier from this simple box to the building. So we right click and hit copy and paste the Volumebreaker modifier to my 3D building. Once we satisfy with the pattern of the fraction, we can go to the Volumebreaker modifier and scroll down to the bottom. There's a element to note. In the prefix, we type in frag for the fracture and check the center pivot and hit this copy and hide button. This will actually break our 3D building into pieces. So now it's time for us to set up for thinking particle. Go to create panel particle system and create a thinking particle in your scene. Here we need two groups. One group is for this red sphere. Another group is of the fracture of our 3D building. So create a property of your thinking particle. In a master system, hit 2 times and create two groups. Rename one as ball, another one as fracture. For the master dynamics, we need to generate a particle from all the fracture of our 3D building. So go to operator, standard, and generate object to particle. For this one, we select all the parts of our 3D building. Select all and mark this as frag group and drag to object to particle and check this instance shape and hit hide and same as for the red ball. Create an operator, generator, object to particle, and select this red sphere. And set the group for ball, object to particle. Check the instance shape and unhide. And remember, for the master dynamics, check this show mesh and switch from ticks to none. So now if we play the animation, we should see our particle. And now we create a gravity to our fragments. Open your particle and create a new dynamic set. The force will apply to the fragment group and create a dynamic force. The direction of the gravity is negative for the z axis. So create a helper, standard, and 0.3. Set the z value to -1. This tells the force node the direction for the force node. And you can play around with the strength value. I set it to 40 and variation 30. And now if we play, it will fall down without collision. Let's set up for the collision. Go to operator and shape collision and select it, create this SC node and create a helper standard node. This node will represent, we will pick this ground floor box, and this node will represent a floor node in the SC, the shape collision operator. Okay. And in here for the SC, we select the group of our fragment, and deflector is the ball. So now if we play the animation, we should see now the fragments are not penetrate through each other. They will have a solid collision between. And because the friction, the dynamic and the static friction are set too high for the default value, we need to fine-tune those parameters. To lower the strength of the friction, select our fragment group here. As you can see, the default dynamic friction and the static friction is 100. We can set it to both to 0 if you want, and play the animation again to see the result. Now, as you can see, we have another problem is before the ball hits the building, the building actually fall down from the zero frames even before the ball hits the building. Go to our thinking particle and create a condition standard time interval. Since we want to turn on the gravity force from frame 40, so we set the start interval to 40 and the end frame is 200. For the force, right click and hit this visible all. You can see this on. We output this time interval to on. So now if we play the animation, the gravity force only enable after 40 frames. So now we satisfied with those building demolition results, we can bake our animation in Thinking Particle. Click our master dynamic and create a new dynamic set. Group for the all group and operator export. Connect those two nodes. Set the quality to 100 and hit export. After baking, we don't need our thinking particle anymore. Select the thinking particle and hit delete. So now, because we have already baking all the keys to all our fragments up and the ball. So now if we scroll the time slider, it will be very smooth. There will be no lag. So as you can see, the FPS of this animation can be very high. Go to rendering setup, switch the default rendering from scanline to mental ray. In the scene, we create a system, daylight system. And change the sunlight to mental ray sun and skylight to mental ray sky. And switch from menu mode. And now we can turn on the enable hardware shading and enable shadow. This way we can see how the shadow direction in our scene. And go to processing and check the material override. You can use the standard material for all objects in our scene. And set the color, diffuse color of this standard material to like clay color. If you want your rendering faster, you can play around with the image precision. Scroll down a little bit. So that's it for this video tutorial, and thank you for watching. Bye bye.